Okay, so this is a summary video looking at the normal distribution. So exam questions on this topic will be pretty varied in a way, but at the same time, if you learn these facts, they're quite straightforward and they pretty much ask for the same I'm gonna say three facts every time in a normal distribution question. We won't be looking at any particular GCSE exam style questions in this video, but we can have a look at them in a later video if it's requested enough. So, a continuous random variable can take one of infinitely many values. Let's have a look at this. A continuous random variable. What is a continuous random variable? Well, earlier we looked at the binomial distribution, which is a discrete random variable. If you look at the diagram on the left, we have x equals the number of heads within 10 trials, and then the probability of getting a head 4 times can be written as the probability that x equals 4. It is a specific outcome because it is discrete. Discrete, remembering from the very, very first lesson of statistics, is only certain numerical values, data that can only take certain numerical values. In this case, we're modeling how many times the coin lands on a head within 10 trials. So if we're trying to find the probability that it lands on a head 4 times, you'd write it like this. Obviously, because it's discrete, it can only take certain values. So you wouldn't be able to have the probability of a coin landing on heads 4.5 times. That's something that's not possible. Whereas if we look to the left, to the right even, we have a continuous random variable. We have y equals the average height of flipped coins. The probability that the average height is less than 20 centimeters can be written as the probability of y being less than 20. What is important to note about the normal distribution is that the probability that continuous random variables take any one specific value is 0. What does that even mean? So we have a coin, we're flipping it, and we're trying to find out the height of the coin. If you're trying to find the probability that the coin is exactly 5 centimeters, that's 0. Why? Because when you're flipping a coin, it could be like 4.1 centimeters, it could be 4.2, 4.3, 4.4, 4.9999999. The likelihood of it being exactly 5 centimeters high when you flip a coin is going to be very, very small. It might be like 0.000001. It's so small that in probability theory, we just call the probability of any specific value in a continuous random variable 0. What you are more likely to see is if you're flipping a coin and you're trying to find the probability that it goes around 5 centimeters in the sky, you're more likely to test the probability around 4.5 and 5.5. This will give you an idea of the average amount of coins going to 5 centimeters in the sky, basically. I hope that makes sense. That does sound like a bit of waffle, but just try process it. Think about it. The likelihood of a coin flipping exactly 5 centimeters in the sky is very unlikely. But if you take this range, you're more likely to get a better idea of how high the coin flips. So yeah, discrete, continuous. Another thing you can see about continuous is it is a continuous curve. It is going continuously along. Discrete outcomes, there are gaps. It's like a bar chart because over here you're going to have like 0.5. You cannot flip a coin 0.5 times. You cannot flip a coin 1.5 times. You cannot flip a coin 2.5 times. That is why discrete outcomes are represented by a sort of like bar chart, and continuous outcomes, because continuous data can take any numerical value, it can be a nice smooth curve, which is more aesthetically pleasing to look at. So here we have histograms. And as you can see, the more data you use, the more bell curved it begins to look. This bell curve is known as the normal distribution. So now we're looking at the normal distribution more specifically. If a continuous random variable has a normal distribution, this can be written as x has a normal distribution with mean. This letter here is mu, and variance sigma squared. Remembering that the variance is just your standard deviation, which is your sigma squared. Standard deviation is sigma, your variance is your standard deviation squared. So yeah, criteria for a normal distribution. It has to have a bell-shaped curve with asymptotes at each end. This bit doesn't really matter too much at GCSE. It will matter a bit more if you take the A level. But asymptotes basically means it goes really, really, really close to the x-axis, but never actually touches it. But yeah, it's a bell-shaped curve, which is symmetrical. The total area under the curve is 1. Basically, if you find the area of any part of the graph, this tells you like a certain probability. So it makes sense that the probability or the area under the graph is 1 because the entire area represents all the possible outcomes, and we know probability adds up to give you 1. It is symmetrical about the mean. So basically the mean is the central point in a normal curve, and it is symmetrical either side. So this will represent 50% of the data, and then you have your mean, and then this will represent the other 50% of the data. It is symmetrical either side of the mean. And very important, your mean is approximately equal to your mode, and that is approximately equal to your median. So all of these facts, you don't get given them, you just need to know them. Know them, learn them, become familiar with them. You will need them. When you get to A-level stats or A-level maths, you have calculators that can pretty much do all of these things for you. But right now at GCSE, you need to know them. So we now have a normal curve drawn out, and we have some things over here. We have our mean plus 3 standard deviations, our mean plus 2 standard deviations, a mean plus a standard deviation, just your mean minus a standard deviation, your mean minus 2 standard deviations, and your mean minus 3 standard deviations. What does all of that mean? If x has a normal distribution with mean mu and variance sigma squared, then approximately 68% of the data lies within 1 standard deviation of the mean. 95% approximately of the data lies within 2 standard deviations of the mean, and approximately 99.7% of the data lies within 3 standard deviations of the mean. You may have noticed that I said 99.7 and not 99.8. This isn't a mistake, but for whatever reason, in the GCSE stats course, they want you to learn the number 99.8. But then when you get to the A-level course, it goes to the correct value of approximately 99.7. So for now, just use this value. But I don't know, keep in mind that it is actually 99.7. So these facts you need to know because you will use these in questions to figure out probabilities. So if we're looking at our first one, approximately 68% lies within 1 standard deviation of the mean. So basically between the mean minus the standard deviation and the mean plus the standard deviation, we have 68% of the data. And then approximately 95% lies within 2 standard deviations of the mean. So between the mean minus 2 standard deviations and the mean plus 2 standard deviations, we have 95% of the data. And then the mean plus 3 standard deviations. So between 3 standard deviations of the mean, we have 99.8% of the data. And because we know one of the facts is that it is symmetrical about the mean, we know that, for example, using this fact, that 68% of the data lies within 2 standard deviations of the mean. Because it is symmetrical, we know that this point here is 34%. And then this other part here is another 34%. Being symmetrical, you can just split it down the middle. And, in total, 68% of this lies within one standard deviation of the mean. So try and familiarize yourself with this information, and we will probably look at more. We will look at some questions in a later video to break down how you would answer or how you would approach a normal distribution question.